Okay, 5.3 writing equations for linear equations and quadratics. So linear equations can be defined and written in multiple ways. Usually most people say that a straight line is defined by 2 points. That is true. A straight line can also be defined by 1 point and the slope. And either way, if you are asked to find an equation based on a given either a picture or some points or some other information, a lot of times it's easiest to do that if we find the slope and 1 point. So let's see what happens if you are asked to find the equation if you know the slope and the y-intercept. Well, that would be probably the easiest case. So if you know the slope, and let's say that the slope is, let's say that the slope is 1/3, and they're telling you that the y-intercept is at a -3, then you could use what most of you guys are most familiar with, y equals mx plus b, which is the slope-intercept form of a line, and just fill it in. So it would be 1/3x plus a -3, so we would often write 1/3x minus 3. So that would be one type. And that would be the first of the two formulas that I think you need to know at this point. So this is called the slope-intercept form of a straight line. Okay, what if you know the slope and 1 point? So let's use the same slope here, and let's say that the point that you're given is 6, 4. Well, you can still do the same thing as you did over here. You can, well, at least the first part, you can still plug in the slope in front of the x and write 1/3 times x plus b. Now keep in mind that anytime they give you a point, they're giving you an x value and a y value. And we know where those values are supposed to go. So we need to have the 4 here, and the 6 should be here. So I'm just plugging in to the equation. The other way to look at this is to say, well, if this point is on the line, then when I put a 6 into the equation, I should get a 4 out of it. So that puts the numbers in the same spots. And then you just solve. So 1/3 of 6 is 2. Move the 2 over, so you get 2 equals to b. And then don't forget to write the actual equation. So it's 1/3 x plus 2. Okay, so that's using the same slope-intercept form of the line. We can do this also by using a different form. So let's say that we're still working on this problem. Okay, you can also use this form of a line, and this is commonly known as the point-slope form of a line. So this is the point-slope form. And I think it's a little easier, and hopefully you'll see here in a second why. So if we look at y minus y1 equals m times x minus x1, then the slope goes where the m is. So the 1/3 goes over here. And then here it says x minus x1. Well, the x1 is the value that you're given. It's the point that you're given. So x minus 6. And then over here it will be y minus, so now this 4 is that y1, so y minus 4. And I would be okay if you left that. So if you use this form, you don't have to multiply anything out. You don't have to solve. You get to leave it like this. Okay? Now if you have to convert between the two, then all you would do is multiply this and bring the 4 over. Now you don't have to do this. I would be perfectly fine if you left that. But for those of you that are wondering if I have the same line, so 1/3 times x, 1/3 times 6 is still 2. And then we're going to add 4 on both sides. And then you see you're back to exactly the equation that we solved for just a moment ago. Okay? Alright, so what do you do if you have 2 points? So what if I told you that, I don't want to point that big, sorry. What if I said one of the points is at 3, 2, and the other one's at a negative 1, 4. Well, you need a slope. Just look at the two formulas that we have. Right? Both of them use a slope, one here and one's here, and you need 1 point. Well, it gave me 2 points, so I can pick either point for that part. The slope I'm going to have to find on my own. And so there is a formula for finding slope. I guess I should have called this 3 formulas over here. So the formula for slope that most of you are familiar with says that m equals, the slope is the first y minus the second y divided by the first x minus the second x. I would just think of slope as the change in y divided by the change in x. And then the way that you find change is actually what they gave you over here. Okay, so if you use either one of those definitions, then we can find the slope. So let's find the slope first. So the slope would be the change in y values. So from 2 you go to 4, so that's a change of 2, divided by the change in x. So from 2 to 4 was plus 2, from 3 to negative 1 was minus 4. So that slope is a negative 1/2. This is how I would do it. A lot of you guys would just fill things in, which is okay. So if this is the first point, that's the second point. So then this would be x2, this is y2, this is x1, this is y1. So a lot of you probably would do off from 4 to 2. So it's 4 minus 2. And then here it is a negative 1 minus 3. A negative 1 minus 3. And you see you end up with exactly the same thing that I did. Okay. Then I would use y minus y1 is equal to m times x minus x1, because then all I have to do is put that slope where it belongs and pick one of these 2 points. So I'm going to use the first one here because it doesn't have any negatives, so I don't have to worry about like double negatives. So it would be y minus y1 equals the slope times x minus x1. And then that would be the equation. There are 2 special cases, and they deal with vertical and horizontal lines. So let's look at a coordinate grid real quick. So what if we had a vertical line through 2? Missed it a little bit. Fix that. Goes right through 2. And you have to write the equation for that. Well, you could try to do the same kind of idea here, and that would be finding the slope, finding the intercept, or finding the slope and then using one of the points. So let's just say that this point is on there, so it went through 2, so 2 zeros on there, and then over here that would be 2, and then that's 3. So if we do this the long way, we then start by finding the slope. So it's y2, so it's 0 minus 3, divided by 2 minus 2. And you get a negative 3 divided by 0, and that should tell you something, because you're not allowed to divide by 0. So this particular equation does not have a slope at all. And that's not the same as saying the slope is 0. The slope is actually undefined here, because dividing by 0 is undefined. So what do you have then? What kind of an equation do you have then? Well, the easiest way that I can explain is to say, well, this line goes through the x-axis at 2. And so the x is always worth 2. And that's the actual equation of the vertical line. This is a vertical line through x equals 2. Okay, let's look at horizontal. And then we'll do this one in green maybe. So let's say I have a horizontal line like this, and it goes through this point, and it apparently also goes through that point. So this point would be 0, 1, and then that point would be 2, 1. So finding the slope here would be 1 minus 1, so subtract the x's, 1 minus 1 divided by 0 minus 2. And that would be 0 divided by negative 2, and that's 0. So a horizontal line has a slope that's equal to 0. Well then, you can actually plug this one in, because we do have a y-intercept over here as well. So if you have a y-intercept and you have a slope of 0, and we use the slope-intercept form of the line, then it says y equals 0 times x plus the y-intercept. And 0 times x is just 0. So you end up with, not this, you end up with y equals 1. Well, that fits the same definition that I said earlier for the vertical line. For a horizontal line, you would just write y equals 1 because the line goes through the y-axis at 1. Okay? Let me do a couple more of these, so maybe you'll see I won't write all that stuff. So let's delete all that. Let's delete all this for just a second. Let's delete all this. And let's just look at a couple more examples of that without doing all that plugging in and all that stuff. Okay. So we just finished with horizontal, so we'll do another one. So what if you had a horizontal line that went right through a negative 4? Then the equation is, if it's horizontal, you just need the variable that is associated with the axis that it goes through. So it goes through the y-axis at a negative 4, and then that's the equation. And that's really all you have to do. So here's another vertical one. So this one goes through the x-axis at a negative 3. So these lines are very straightforward. You can just write the letter of the axis it goes through and then the point, and then do keep in mind that the vertical line has a slope that is undefined, and the horizontal line has a slope that is equal to 0. Okay, the horizontal line doesn't go up or down, so there's no change in y over change in x. And the vertical line goes both up and down, and since slope is supposed to tell you that the line either goes up or down, it cannot go both, so it's undefined. Okay, that's for straight lines. We also should be able to write a couple of quadratics. Now, quadratics can be more difficult because we usually need 3 points, but if we are given a vertex, then that actually makes life a lot easier. You can actually get by with just a vertex and one other point. So we're only going to work on that very specific example, and that means we're only going to worry about the vertex form of a quadratic, which would be this, right? Where h and k is the vertex. So we're going to use just that. Right. So let's say that I know that the vertex is at 2, 3, and that the next point on there is 4, 7. So I have to tell you which one's the vertex and which one's the point. So the 2, 3 is the vertex, and then 4, 7 is another point on the quadratic. Then we should be able to figure out what the quadratic is. So let's see what we get over here. So plugging this in, then this would be an h, and then this would be the k. So I'm going to write y equals a times x minus 2 squared plus 3. Now the idea here is the same thing as what we did earlier with the straight lines, and that is that this is an x and then this is a y. So you can put the 7 where the y is, and then the 4 where the x is. And now you just need to solve. Now there is a little bit more involved to solve here, because 4 minus 2 is 2, and then you have to square it, so that's 4. And keep in mind that the 4 is multiplying the a, so you get 4a plus 3. It's not 7a. Then you subtract 3 on both sides. So you get 4 is equal to 4a. That means that a is equal to 1. So the equation for this parabola equals y equals 1 times x minus, keep in mind that we know the vertex, so it's x minus 2 squared plus 3. Okay, that's fairly straightforward, hopefully. Let's do the same, but let's change the point that's given. Let's say we are still at 2 and we are still at 3. That's still the vertex. Then the next point over is still 4. And instead of it being 7, let's say that it's a negative 5. Let's say that that's the point. Okay. So the same steps. We're going to plug in the vertex first, and initially I would do this one at a time. What I mean with that is I would write y equals a times x, and then minus 2 squared plus 3. So plug in h and k first, because that's h and that's k. And then plug in x and y so that you don't mess up the order, for example, in here. So the y value that I need is a negative 5, and that y value should occur when I use an a of 4. Okay, and let's solve it. So 4 minus 2 is still 2, and 2 squared is still 4. So I get a negative 5 is 4 times a plus 3. Subtract 3. So it's a negative 8 is equal to 4a. And that means that a would be a negative 8 divided by 4, which is a negative 2. So then the equation becomes y equals, a is a negative 2, and then it's x minus the 2 squared plus 3. So notice that it is possible to get a value different than 1 here. So a lot of times we end up with 1 here, and if we do have a 1 there, keep in mind that a lot of times we would just write it like this. So it's an x minus 2 squared plus 3. But you do need to solve for a because, you know, we can flip the parabola, which is what happened in this case. Because look at this here. If 2, 3 was the vertex, so that's 2, 3, right? Then 4, negative 5 would be over here. So if you put this on a coordinate system, sorry it's a little crooked, but at 4 you would be down here. So you can see that this is a parabola that went down. Whereas the first one that I drew, if the vertex is at 2, 3 and the next one is at 4, 7, so 4, 7 would have obviously gone up. And you need to be able to solve for both of those situations, and if you do the math right, it will just solve itself. Okay? Well, that's it. Thank you.